Okay, so here is a problem similar to the one you are going to answer. You can see here that in step 1 of this pattern, we have 3 dots. In step 2, we have 1, 2, 3, 4, 5, we have 6 dots. Over here in step 3, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 11 dots. So if you think back to the beginning of this unit when we were talking about quadratic equations, quadratic functions, we looked to see whether or not this difference between the number of dots or whatever shape you're dealing with was consistent. So here from 3 to 6 we're adding 3, here from 6 to 11 we're adding 5. That is not common. So then we took a look at the second difference, and that's going to be a +2. And so if we were to continue that pattern, over here in step 4, we would hope to see that if I added 2 to 5 in this next number, I would have to add 7, which would mean my pattern should have 11 plus 7, or 18 dots. So you can check the pattern that you have to make sure that there are in fact 18 dots. And because it's quadratic, we now know that it's going to be some number getting squared. And so we can check that. If it's step 1 and we do 1 squared, well, 1 squared is only 1. So that doesn't quite get us the answer we need. 2 squared is 4. That also doesn't quite get us the answer. 3 squared would be 9. Still not the right answer. 4 squared would be 16. Still not the right answer. But check this out. In order to get to the right answer, in other words, to get from 1 to 3, I could add something. And to get to 4 to 6, I could also add something, hopefully the same something. 9 to 11, also adding something. 16 to 18, also adding something. So the question is, what has to be added here to finish out the answer to this problem?